Okay, so let's suppose that potato crisps are sold in a bag, and the masses of the bags are normally distributed with mean 50 grams and standard deviation 10 grams. So let's just whack a bit of notation on this to start with. Oops. X, the mass of the bag, is distributed as a normal random variable 50, 10, right? That's the parameters for our normal distribution. Bags that have a mass outside of the range 35 to 65 grams are called defective. So obviously we don't want a bag too light because our customers will feel ripped off, and we don't want our bag too heavy because we'll be eating into our profit margins. What proportion of bags under this distribution, right? What proportion of bags are not defective? So the ones that we can actually sell. So we're going to have to work through what we know about the normal distribution to be able to compute this probability. So let's firstly work out what we're supposed to be computing. We want the probability that X is bigger than 35 and less than 65 grams. Okay, so that's the probability that we're after. So we firstly look at our normal distribution that's centered around 50. We got 35 here. We got 65 here. We want to re-express this in terms of what's tabulated. So things that are tabulated are like this quantity here, right? So we want two less than inequalities. Right, so obviously we're happy with the 65 one, but we're not happy with this 35 one. So we can immediately compute the probability that X is less than 65, right? That's the yellow area. We've got to subtract off this red area to get the purple area that we want, right? So we've got P X less than 65 minus P X less than 35. That's the probability we want. So we take the yellow thing, we subtract off the red thing, and we get the purple thing. All right. We'll also note that what's tabulated is the standardized Z-score. That is the distribution, the normal distribution with mean 0 and variance 1. So we've got to convert this expression into a Z-score. We've got to standardize. So to standardize, we subtract the mean, 50, and divide by the variance, which is 10. To deal with this minus 1.5, again, we just use symmetry. Oops. So this is our normal distribution. Oops, worst normal distribution ever. Like that. We know that, for example, we're down here at minus 1.5. We want this area there. We know that it's equivalent to this thing up here. So we know that that's equal to 1 minus the yellow area. Now the yellow area is something that's tabulated, so we can compute that. So we can redo this as brackets 1 minus P Z less than 1.5. So that's 2 probability Z minus 1.5 minus 1. Okay, this is now an expression, this is now an expression that we can compute, right? And we can compute it by looking this thing up in a standard table. So here's a standard table. Tables represent the area to the left of the z-score. So we want 1.5, right? That's that quantity there. What's less than that z-score has the probability of that happening is 0.93319. So it's 2 times 0.93319 minus 1. So now we've got to take this and stick it into our calculator. That turns out to be 0.86638. So there's 86%, 87% of bags which are not defective. They're within our saleable range. Okay, we do have a second part to this question, which I'll address in the second video.